Good evening, everyone. A warm welcome to one and all who joined to this session. Welcome to our speaker Harigovind M, and it's the second day of our workshop on Introduction to MATLAB and Simulink conducted by IEEE PES CUSAT. Without any delay, we can start with our today's session. And to the attention of for all participants, if you have any queries in between the session, please put it over the in the chat box. Hoping for a great interactive session, I'm handing over the session to our speaker, Harigovind Cheta.
Thank you, Shivapriya. I believe I'm audible, right?
Yes, Cheta.
Okay, great. Good evening, folks. I am trying to share my screen. Please let me know once it is visible. Yes, I believe it's loading. Okay, got it.
Yeah, it's visible.
Oh, great. So yesterday, I'll just go through quickly for what all we went through. We went through what is MATLAB, why do we need simulation, and what is MATLAB, what does MATLAB stands for, what are the uses of MATLAB, and we started doing some small how we tried defining variables which are scalar in nature. All the, as I said yesterday, all the variables which are stored, which we initialize in MATLAB, will be stored as a value, as in a matrix. And we further went to define the conditional statements like if else, as well as switch statements. Then we went for loops, for loop and while loop. And then we started Simulink. Simulink is something within MATLAB, a model simulation tool, equation-based simulation tool, where we tried plotting one or two diagrams, slide diagrams. We went through its libraries, went through the source and sing libraries, and mixed one or two sign signals, viewed what all are visible, how both signals can be simultaneously shown in a graph or a plot, etc. And further, we did a small problem, a mechanical problem rather than an electrical problem. We did a mass spring damper system. We illustrated that in Simulink, and we hopefully got an answer. Today I will continue from this from here. Yesterday I will open the file. You can either open a file by going through the current folder, or there is another way. Just it's getting loaded. For that, in the typing, we'll go to MATLAB. So if you want to open something, or if you directly want to open Simulink, just type Simulink. Or if you want to open a particular file in Simulink, just type sim bracket the name of the file. Name of the file should be matching with the file name. That is, it is Spring. You write SPRING, Spring. We click enter. It will take some time to load, but yeah, okay. Yeah, it is loaded. So whatever file it is been simulated. The sim stands for simulated. The first operation, when we give sim spring, what it does, that it simulates, rather than opening the file, it simulates the plot or the block diagram which we created. This is what we created yesterday. Our equation was, this was the equation. F is equal to MA. MA stands for the force provided on the mass, BV, force provided on the damper system, and Kx is the force provided by the spring. That is, the force provided on the mass is Ma. We have Cx or minus. It is counteracting the mass of the block, so it is minus. Both spring and damper, whatever mass is, whatever force is applied on both of these devices, it is counteracted. So that is why we are having a minus sign. It is minus Kx and minus Cx or Px. So since what we are looking for is the displacement. We want to plot the displacement. Displacement is x. X is a linear displacement. So for that, we want every equation in terms of x. So we changed a, v, and x in terms of x. That is, A stands A is dx square by dt square, V is dx by dt. Thus we got an equation and we tried plotting it here based on that equation. We brought we brought A to one side and the other equations to other variables to the other opposite side, that is RHS. Hence plotted this graph and we got a corresponding result. So as I said yesterday, every time if you want something and if you want to plot something, it is if you want that in Simulink directly, you want to convert that into an equation, which is most of the time, if the system is small, if the question or what we want to simulate is a very small thing, then it is possible. But as the system becomes bigger and bigger, it is quite very difficult to change everything into equations. So what we can do is that there is another type of tool or a library which is available within Simulink, that is Simscape. Simscape is a library that is, if you go to the library browser and you have to externally, if you have downloaded simply MATLAB and Simulink alone, you may not find it. You have to download it additionally. That is the Simscape. There is a library known as Simscape. And there is a foundation. In the foundation library, you can go for so many things. You can do electrical models, pneumatic models, hydraulic models, mechanical models, etc. So many things are available, and detailed systems are also available. In Simulink, like in Simscape, like Simulink, there is something known as foundation library. That is a basic library available. In that, if I click electrical, you will get electrical elements like capacitor, resistor in physical form. Like if you want to design a schematic diagram, you can directly drag and drop this current system here and do accordingly. I will show that. After this example, we are going to show another example. So what we are going to do is we are going to model this physical thing. So right now, if you can see that this is known as dashboard. Okay. Yesterday, what we did was we had something known as scope to visualize the block diagram or the answers, the output. So only after clicking the scope, we will get the output. So if you want it in real time to see within the canvas, there is something known as double click anywhere in the canvas and click just type dashboard or dashboard scope. If you click dashboard scope and double click it, a window will appear, and just whatever signals you can take multiple signals with these. You can, if you want the output signal like this, you click it, then just type the signals. The arrows should be clicked, not the devices, and select it. And if you want the something else like A, and click it, and you can click apply. And once it is simulated, you will get both. Okay, both the signals. It's load. Okay, so I didn't click the A as it is. And if you again go for a simulation, okay, now we have both A and integrate. A is quite big. You can compare both the signals and format it accordingly. You can for some clearance, we can change the style. We can change the display style. Let A be a dotted thing. Just go to the display, change the style settings, and give apply. Okay. Now while zooming that, or the main disturbance occurs within 0 to 20 seconds. So we can change the time span to 20 seconds. Just go double click the dashboard, go to the main, and there is something known as time span. If you want, it is currently in 150 seconds. So if you want to do it in 20 seconds, then we can give apply. Okay. Yeah. So this is the disturbance in 20 seconds. You can see A is very large compared to the displacement. Acceleration, the jerk or the change in acceleration is very large compared to the displacement. So that's how you can analyze it both. It's not two, multiple signals can be analyzed using this dashboard scope. That is very useful once we are doing the simulations. So we can plot this. We have the question here. So if we have so many signals or so many systems within a single file or a single canvas, and if you don't want that to run, so every time if I am clicking running, then the both the models are getting simulated, and it is taking so much memory, and it is making the system and output slower. So what you can do is that you can drag that, and there will be a three dots, and there is something known as comment out. You can comment it, and whenever it means that it is not deleted, it will be there, but it won't get executed. So once you give comment out and create, whenever we put or give run, these models are not executed. Rather, what else are there that will get executed. So we can make the model. We have this diagram. Just keep this diagram in mind. And conventionally, you can go to library, go to scroll down to Simscape, go to foundation library, and go to mechanical model and translation items. These are linear motion items. All those things. Spring has linear motion here. Damper has linear motion. Like to a motion that is linear motion rather than rotatory motion. So we have to go to mechanical translation motion, and you can find a mass. Just drag it. We have a spring, and we need a damper. So this is the mass, this is the spring, and this is the damper. The C's can be considered as the negative side or common side. Here, this is the common side. So C, whenever you R and C, R is the main positive part. If you can consider like that, and as an analogy, if you can think what is R and what is C. So R usually is the positive part, and C is the common part, which is the base part. And you want to rotate it, just press Control R. This is also Control R. So it is almost, and this point is where mass is getting connected. So in order to make similar to this, to change this figure to similar to this, the reference figure, we can rotate it and connect it accordingly. Just join these two and join. Okay. Now we want a reference. Normally for any simulation in Simscape, whether it is mechanical simulation or pneumatic simulation or electrical simulation, you need a reference. And if you go to the library, or if just you can double click and search for electrical reference. Electrical reference, there will be so many several electrical reference. You have to give stick on in the path electrical. It's not electrical, sorry, it's mechanical. We are creating a mechanical system. So just type mechanical reference. There is rotational reference and translational reference. All these things are translational in motion, does translation motion. So we have to give a mechanical translation and just connect it. Okay. Now the system is created exact to this given problem. What we need is that this is a physical system. These Simscape systems are known as physical systems. So we need to integrate it to Simulink. Simulink only knows how to solve differential equation. If you give run button, what it does is that it creates several similar differential equation, and in numerical method solves differential equation and plot accordingly. But this, since it's a different kind of library, even if we give run, there will be an error because Simulink does not know. It is ran in the Simulink. So you want to change these things, or you want to solve these equations just like we did yesterday, like this. If we are giving like this, then Simulink directly will run this. But as a physical system, you have to add every time you work on Simulink, Simscape, you have to type something, you have to add something known as solve, or it is the tool which converts the physical system into differential equation and help us to simulate. As earlier, both are different systems. What Simulink system and Simscape systems are different. We have to interface. If we want, the output is shown in a scope which is part of Simulink library. So in order to interface both Simscape and Simulink, there is something known as Simscape or physical system. There is something known as PS search for PS Simulink converter. PS stands for physical system. Physical systems, and there is there is also Simulink PS system. If you want to take our DC power to from Simulink and give it on a resistance or anything like that, then we have to use Simulink PS converter. So we have Simulink PS converter. Now we need something to measure. Okay, we are going to measure. This is a spring, so when it is getting compressed, there is a linear motion, or there is a change in distance. So we need something to measure distance. So if you type, we have something known as, or just go to the library. If you have any doubt in that, just go to mechanical and mechanical sensors. There is something known as ideal translation motion sensors. You can give this, or if you are measuring, we can give this accordingly. If it is force in rotation motion is known as torque, and just drag and drop the measuring device. You can see there are connections. Just try to rotate it. The C is it is voltmeter. You have to connect parallelly. So C should be connected to C and R should be connected to R, and it can measure both position and velocity. But we don't need velocity, we only need position. What we have to do is just either there is an option to terminate, or you can keep it as it is. Here we are going to keep it as it is, and we are only going to take what we need. That is, we only want to know the position change in spring. So that's why we are going to take this. And now up to here it is SimScheme, and from here we can take libraries, we can take blocks from Simulink. That is, we can, to visualize something, we use scope. So we can connect scope. So this is a system. We have spring, we have a damper, we have mass. Give values. We can give exact values. We can check the values of the. It is 0.1. Okay, 0.1, 10, and 400. The mass is 0.1 kilos. The spring has a spring constant 400. And damper has a damping coefficient 40. So everything is in. We have the system. We have something to read the system. We have something to see the output. We have something to solve. So everything is on place, and we can hopefully run the system. Okay, it's 50. It might be there is something wrong. Motion is there, 40, and you can additionally yesterday we can add, like if we have an initial spring is initially compressed to some other values, then we can give either 1 or 2 meters, like whatever the values, we can give the initial conditions. Just click spring, go to variables, and if you have an initial velocity, we can give that number. If you have a force, etc., deformation, etc., anything stands for initial change in length. Solving is we don't have to change anything in solver. There's some change here. We'll do one thing. We'll create a dash scope and directly visualize what is happening here. Just double click. So it will ask to select the type of signal which is to be measured. So you need this kind of signal, and you can give apply. You can click run. You can change the time span to 1 or at the 0.1. Okay. This is something which I created 1 hour ago. We can just check this output. This will be same as this. This is yesterday's work and this is today's work. So if you want to comment out something, select it, go to 3 dots, uncomment, click uncomment, and simulate it. Okay, it is same. Then we have to give velocity terminator. Okay, ideally this, if we don't want something, we have to terminate it, and there is something known as PS terminate. You don't want that signal, and if you want to suppress that signal, what can be done is we can give a block known as terminator block, and when you can click run. Hopefully you will get the answer. It is 10 kilogram. Okay. The mass is very low, very small. Okay, yeah, now we are getting an answer. Here there was no deformation, so we can change the deformation here. You can see this is the result we got. There is an initial jerk and it is going to steady state. And this is yesterday's work. Suppose if we want, we have so many systems here. We have one here, we have one here. So it is pretty much congested everywhere, and you want to make it into a small optimizable way. So what you have to do is you have to select whatever thing you have to do. You want. There is an option to create subsystems. You create subsystem, everything will get confined into a small block, and you can, if there is an input and output, you will get an output here which you can connect. So we have both, and whenever we need, we can click that system and analyze it. Similarly, if you want to go out of that system, just right click it. There will be so many options, and there is something known as subsystem and model reference. Expand subsystem. So subsystem is expanded, and if you don't want this outer covering, just delete it. That's it. So we can just verify this, whether this is what we did yesterday. Sadly, there is no change, and this is what we did today. We developed it physically here, and we developed using equations. Both illustrate the same thing. So before going through that, we can just uncomment that. Just select uncomment. Okay. Just drag this scope, or just delete this scope for the time being. Okay, now we have two systems. This is what we created yesterday, and this is what we created today. We can compare those both. Yeah, this is what what you are getting using equations, and this is what we are getting using physical systems simulation. And if we want to compare previous simulations, there is something known as data inspector. Once we click data inspector, and those are Just click the signals you want. Okay. And if you want to compare it, just go to compare, and the reason, just go and this is 40-second. Today I did the 40-second simulation. The last simulation which we did is the 40-second simulation. We can compare that to 49 and the previous one, that is 42. If you give compare, this is what we get. There is a change. But if you give what 30 and 30, like previous simulations, yesterday's simulations and today's simulation, both are same, exactly same. Simulink 1 is what we used in using Simscape, and Simulink 30. The 31st simulation is using Simulink. So there is this one superimposes one figure with the other. So you can see there is not much change. Everything is same, and this gives whether there is any difference or what is the difference. What all are the difference between, to compare both, and we can get all the necessary values from here. So this is a super tool which can be used to compare each and every simulation. You can find that in something known as the data inspector. So, but before you to initialize data inspector, you need something. You need to activate the dashboard graph or dashboard scope. That's about what Simulink does and Simscape does. The next thing which I would like to cover is test one. What was test one? Yes. Let me just give you an overview of what a plan is. Yesterday we did something other than creating simulations. I said that you can do it using a transfer function. So what is a transfer function? Theoretically, a transfer function means it is a big thing which you guys will study in control system. It is a Laplace. It is defined as Laplace of output of the system by input of the system at zero initial conditions. But I am not going to focus on that. That is a theory part. Rather, we are giving something to get something, right? So where we are giving, that is known as plan. So we are giving a force and we are getting an output, a change. The place we are giving or the modification, what the work is done by a system, that system is known as plan. Or plan is a system which transforms an input to the desired output. So suppose this is the plan. Just we have a signal, step signal. This is a constant signal. Currently the value is 1. So output is 1 throughout. Okay. And we have something. Okay, we'll recreate here. We have an input step, and we need this step to get something into something else. So we need a planned or a transfer system or a system. So what we do is we create a transfer system, transfer function. When we double click it, you have to give coefficients or numerator or denominator coefficients. What are numerator coefficients? What are denominator coefficients? Here you can see this is yesterday's example. F is equal to MA minus BV minus BX. If we change into A in terms of X, we are getting like this. Suppose say d by dt is S. Just give d by dt S. S stands for Laplace transform. It has another beautiful value meaning, but for the time being, ignore that and just make it into an equation. So if d by dt is S, dx square by dt square is S square, and S, etc. So we will get ms square minus bs minus k. Okay, and say if it is g of s, f of s by g of s, that is output by input. We are making in terms of transfer function. Output by input is, if we divide this by, if ms square minus bs minus k is say g of s, if we divide the same here, we'll get 1 in the right hand side and we'll get f by s by ms square minus bs minus k in the right hand in the left hand side. So what we get is 1 by ms square minus bs minus k. If you are giving some values to this, we will get ms square minus 10s square minus 10s minus 400. And the coefficients of s square, s and s raised to 0 or the constant, we have to represent here. And since the numerator is 1, we are giving here 1. And since just like that, we have to give the respective. The first one, if we have three constants, the first will be the coefficient of s square, second will be the coefficient of s, and third will be the coefficient of the constant. So that is a transfer function, and we can see the output. To duplicate something, just give the control signal and drag it, and just run that. Okay, this is the output of the signal. It is linearly, to some extent linearly increasing. Okay, normally if you need to control something, you need to have take the output and compare it with the input. Then only you can know what is the change and act accordingly, right? But there is nothing is taking output, or we are not controlling output here. Rather, we are just giving some input and we are taking some output. So to avoid that, what we can do is that we will take an output, take a point from the output and give it to input. This is known as feedback. And we can give either positive feedback or negative feedback. So to add or subtract something, to give a feedback, we can either add input and output, or subtract input and output. Normally we subtract input and output so that there is an error. And when the error becomes 0, the input and output remains the same. That's how we are going to get the desired. We are controlling the system. So we need something known as sum. Just connect it. Take a junction. That is, click control and give it. And as I said earlier, it should be this signal minus this signal. So this is plus and this is minus. Okay. Now this is known as a feedback system. This output is getting feedback, and both input and output is compared, and it is given to the control transfer system or the plant. This is also known as plant. If you hear plant, it is nothing but the system which is acting upon both input and output. Let it be for the time being. Now it is, we can increase the simulation time. What we need is that we want here 1, but we are not getting 1 here because input is 1. Okay, we are getting 0.5. It's because of the system. System is going to 0.5 because of what all the changes that is happening here. So that's how you do a plan. But you need to make this output close to input. So if you want to compare input and output, just click the dashboard and click the uncheck those two signals and click the desired signal. So we need the output and we need to compare the input. Just we want the step signal and you also want the plan signal. You apply. If you run it, yes, this is the output and this is the input. These are, yeah, it is getting into a steady state, but it is the half of what we want. So we will use something known as PID controller controllers. Controllers are mainly PI, proportional, integrate, and derivative controllers. There's a good article here. I'll ping that chat. Just these are all theory. So I'll explain quickly what we need. What is a control? It explains controller. Namely, there are basic three type of controllers: proportional controllers, PID controllers, derivative controllers, and its combinations. So proportional controller, what it does is that it gives an output proportional to the input. And the advantage is that it makes the system more stable and it is fast. But it itself has a disadvantages. Then we'll go to that's why we started developing integral controllers. That is, the output will be proportional to the input. Sorry, integral to the input. It has its own advantages and disadvantages. It makes the system unstable. And we have derivative controllers. Derivative controllers, it is the input output is proportional to the derivative of input. That's how it does. So what it does is that it makes the system a bit slower. So everything has advantages and disadvantages. So what we used to do is that we will try combinations, either PD or PI, or IDs are not commonly used. We'll use only PD, PI, or PID, all the three. So in MATLAB, we have an option to use, we'll get a block known as PID controllers, where we can change, we can okay. So where we can change the values of P, I, D respectively. So if you double click that, you can change the values of P. Defaultly, it should be internal. You can change the value of P, I, and D. Defaultly, the derivative constant will be 5. So let the constants be 5. So I'll give you the difference, and I'll also further help you how to tune these controllers. These are very important in developing any system, whether it is power electronics, whether it is power systems or control system, anything. It is an integral component of MATLAB and Simulink. Now, if you see, it is getting close to 1, but there are so many problems. There is a jerk, or there is an instability initially. The steady state and it approaches to the steady state error is very high. It is not a steady state error; it is very high. So this 555 is not a good option. So you can either just give it randomly, just give any number and do it trial and error method, or MATLAB itself has an inbuilt function known as tuner function, or if you in a transfer based tuner, PID tuner. If you give open, it will take some time to open, rather less than 5 to 10 minutes. You can only do okay. It is getting started. It is a very good thing, and these are currently used in our. You can use this in your mini project and project to use control devices, motors, servo motors. You can get the values from here, and you can give the values and actuate it using embedded systems such as ESP32 or Arduino. So this is the system. So okay, so tuned response. So this is, if we change the value accordingly, we'll get, I will maximize it. Okay, if the value of P is 1.63, I is 0.299, and D, don't ignore N coefficient, filter coefficient for the time being, and D is this, you are going to get this solid line graph. So that is good. So this is our graph. So we can, if you want to make it faster, then it is getting to steady state much faster compared to the last time. But what you have to sacrifice the peak. The peak will increase as you move to faster and faster. The initial peak will surge, and if you want to make it increase the disturbance or flatten this peak, you can change it to robust. So it is sacrificing if you both. That is, or you have to find an optimal value by dragging these cursors and stabilize it. Okay, I think you got the point. If you want to make the system faster, you can do like this. You move to the right. If you want to make it robust, you can do shift the cursor to right as well. Okay, the more you make aggressive, the more the peak rises. Okay, now it is comparatively okay. It is much better than our signal. So we can give update. Once we give update, the PID control values have now changed into the desired values. For this, it is automatically changed. Now, if you run that, yeah, it is good. You can never get an ideal step signal. It is an ideal step signal, which is almost impossible. So, but there will be some transients. These are known as transients, and you can minimize the transients using PID controllers. So it's a very good app. You can control and you can analyze all the devices, physical and non-physical devices. So that's about PID controllers, new transfer functions, etc. We'll come back to SimScape. I did something on a mechanical system, that is mass spring damper system. Now we can work something electrically, which is close to electrical and electronics. Using this physical modeling, we can develop an RC circuit. You can see there is an RC. There is a DC source. It's a simple circuit, DC source in series with a capacitor, in series with a resistor. That's it. And we are going to check the output. What is the output across voltage? We are going to measure the voltage across capacitor. So how can we do that? Either you can type, or preferably initially just go to SimScape. Okay, I'll just. Okay, this is how you get it. So just scroll down, go to SimScape, go to Foundation Libraries, go to Electrical, click Electrical Elements, drag a capacitor. You need a reference, a ground. Drag a ground, and there is a resistor. And you will get all the details, what it is, how to connect, etc. while just dragging your cursor to the desired component. And thus you need, okay, thus you can make a DC source, a capacitor, a resistor, and a ground. And as I said earlier, at the end, Simulink only knows how to solve differential equations, and these are physical systems. Yes, so there should be something which can translate the system to differential equations or equations. So Simulink is an equation-based solution module. So just give the solution like this, or just give solution configuration. So every time when you use a Simulink model or something like that, you have to give solution solver equation, because if you don't give it, there will be error that these things are not defined. I'll show you what is the error. We can run this. This is the equation. We are getting some equation. If you click that, this is how capacitor is getting. This is how the voltage across the capacitor is rising. Due to the transient effect of capacitor, there is a delay. So what if we delete this solver configuration? We are going to get an error. That is, none of the thing are the system is not knowing what is this, neither the voltage source nor the reference or the Simulink converter. It is not able to identify any of this. It is that block that is changing the respective models to Simulink equations. So never forget this while using. Yes, you can connect it to anywhere, any point. Just connect it to the circuit. It doesn't matter where you connect it. And just like physical measurement, we are going to measure voltage across capacitors. So there should be something to measure the right, like a voltmeter. Here we have something known as sensors, electrical sensors. There are current sensors close to an ammeter or voltage sensors. You track a current sensor here, you will get a plus and minus point. You can connect the plus point here to plus part and minus point to the minus part of the capacitor, and you can there will be V out. And as I said earlier, scope is part of Simulink library, and these are all part of Simscape library. So there should be a converter. This is physical state PS hyphen, if you give PS hyphen, yes, PS Simulink converter. If you want to check the current, we'll check the current for the time. So just rotate it, connect the positive to positive, connect to negative. We want converters, so click control. We are copying this. Okay, yes, converter. The value of physical value is getting converted into simultaneous value. Now we have both volt. We can run that. Okay, we forgot something. We forgot to add solver configuration. That is this block. Click it somewhere. Just drag and connect it to somewhere in the circuit. That's all. Current value is very, just adjust the, it is auto scaling. Okay, so current is decreasing since capacitor blocks DC current due to transient. It gradually comes to zero, and in the voltage part it is increasing. There is a slight delay due to capacitor, and it is going to the steady state. We are giving 9 volt DC, so that's why the DC is given 9 volt. The capacitor resistant value you can change it to any ohm possible. You can give 100 ohms, kilo ohms, mega ohms, etc. You can give capacitors. The capacitor value is currently 10 microfarad. It will be e raised to minus 6. Whenever e comes, it is an analog 10. E 1 e raised to minus 6 into 10 raised to minus 6. When you want to give a exponential component of our 10, a multiple of 10, just give small e to the power 6 means it is 1 into 10 raised to 6. If it is minus 6 means 1 into 10 raised to minus 6. E stands for 10 in MATLAB. I hope you understand. Any doubt till now? We discussed to use Simscape in mass timber system. We solved RC circuit, and we talked about what is planned and how to tune PID. So can anyone respond in chat box up to this point? You can also speak out. Okay, I will. If you have any doubt, I can explain that in Malayalam as well. We respond so that move to the next part. Someone please give your answer in the chat box. So I was speaking. Am I speaking in mute, or you have not understood anything? That's what I should understand. Come on, guys. Respond. Please respond so that I will. Okay, got an idea. Great. You got an idea. That's it. That's what I wanted. I don't want any of you to understand it completely, because if you understand it completely, you will think that that's it. I know MATLAB and I'm going to, because there is so much to learn about MATLAB. I only want you to get an idea. That's all. That was my purpose. Anyhow, without much ado, we will go for release. Now we'll do something different. Okay, we have one more project remaining, a diode. We are going to create in Simscape using half wave rectifier using a single diode in Simscape. This is the respective system currently. So you want an AC? Yes. Last time I showed you a DC system. This is an AC system now. So the best thing, just search for AC. AC voltage source is there. Current source is there. Make sure that it is found in foundation library, because there are several libraries. You have an AC source, and now we want a diode. Foundation diode is enough for us now. See, each library has its own purpose. It's not that we have to use basic foundation libraries every time, but for this illustration purpose and every tool, if you are taking something from one library, then all the things should be in that library. Like you can't take this from foundation library and this from power system library, etc. You can't do that. There will be an error. We have a diode. We need a load, that is a resistor, dissipate the power. Okay. Just connect it. Connect the positive to positive of diode, negative to positive of resistance, and that's it. A small circuit. Now we need a reference, a ground. That is electrical reference. Just click electrical reference. Drag electrical reference. So the circuit is complete, but to solve the circuit, get the answer, we have to give additional blocks. And one such block which we have to give is solver configuration block to solve this differential equation. And we need to, what we need to read the voltage across the resistor. Okay, we'll do one thing. We'll connect a voltmeter or a voltage sensor parallel. Either you can type voltage sensor, or for me, for ease of the function, I just copy a voltmeter or volt sensor. Okay, you have a voltmeter, but these are all physical element. We Simulink cannot read this, so we need a converter. We'll PS hyphen, should be capital letters. Okay, PS hyphen Simulink. So we are converting the physical, PS stands for physical system, to Simulink, and now we can have a scope. Normal scope. Okay. We have the diode. You can specify the AC voltage. Let AC voltage be 5. And there will be a problem. I will show you the problem. Resistance 1 ohm. Let it be 1 kilo. Kilo means high dissipation. Okay, let it be 100 ohms. Okay, the circuit is hopefully complete. We will check for an error. Actually, it's a program, so whatever you type or drag a block, in the back end, these all are set in C programming kind of instructions, which is being executed by the compiler of MATLAB. Okay, we are getting, since we are giving 50 hertz every every cycle is 20 hertz, 20 milliseconds. So that's why you are getting a big disturbance kind of thing when we just zoom it. Oh yes. This is actually how a diode works. In the first, this negative half cycle is clipped, and we are getting the positive half cycle. So if we want to compare that with the input, what we can do is that we can connect a voltmeter across the input, that is the AC voltage source, and we can give two scopes. Or easy way is that keyword dashboard, scope, double click it and move your cursor to which signal you want. Connect it, another. It is loading. You can also simulate it from here, okay? So this is how simulation happens. You can see the sample time. We have given 10 seconds. So now it is 4. These kind of simulations are very useful when you're doing power electronics related projects, like using MOSFETs, IGBTs, SCRs, etc. This is our AC way. So if you want to see both, the one way is increase the port to 2, or you can multiplex it. In either way, it's possible. If you click stop, the simulation is not getting over. Click run again. You can see that since we are using the resistor, a 100 ohm resistor, the amplitude is getting reduced, and since we are using a diode, the negative is getting cropped. So the voltage is there is a voltage drop across resistor. That's why we are getting an amplitude less than the input voltage. If you want the amplitude to be same, one of the ways, give it 1. Okay, it's a 1 ohm. So there is a resistance. Give it 0.0001. And we give start. Now there is no current. We have output voltage, but there is no current. The decrease in resistance, you can't change any values during simulations. Okay, the simulation is getting completed, but that's why even if you click any of this, you can't change its value. Now once the simulation is over, you can change the value. Either you have to click stop, or pause is not enough, so you have to give stop. So that's how you can work on Simscape, and you do your schematic simulations using diodes, transistors. There are so many things available within. Let's go to the library. You can see foundation sources, but if you go to the specific electrical library, you can get the source things, sensors, semiconductor devices like normal diodes, IGBTs, current limiting sensors, all those things. MOSFET, JFET, IGBTs, optocouplers, everything you can get it from these libraries. Next, finally, we are going to explain something different. Suppose you want to model your Arduino, you get to program your Arduino with MATLAB. That is also possible. How you can do it? That you have to go back to MATLAB. So this is the MATLAB start. There is something known as add-on. Yeah, you have to log into your MATLAB account. Okay, to do that. The path is Go to the home page of MATLAB. Give add-on. Add-on Explorer is not okay. Get hardware support package. Okay, currently I have a pre-release package. Okay, that's not okay. I reinstalled my MATLAB yesterday. Normally you will get all those necessary libraries, new libraries, which is user-defined libraries in MATLAB, and where you can search. We will search MATLAB. After signing in, you can download. Okay, it's loaded. It's getting loaded. You can have. There are 3 things available: Arduino support for MATLAB, Arduino support for Simulink, and ThinkSpace support for desktop MATLAB. Okay. I prefer, if you are working with Arduino frequently, just download Arduino support from MATLAB and Arduino support from Simulink. Once you do that, sign in, there will be a package, and install it. And go back to Simulink. Okay. So after you download this MATLAB library, after signing in, you scroll down, there will be something known as, I haven't downloaded MATLAB for Simulink. Currently I have downloaded Simulink support package. There will be an additional, this, before downloading that, you won't find this library. Only after downloading that specific library, you in this site, I'll share you the site link, or just Google it, that would be better. There will be something known as Arduino support package, and common things. Common things are also found here. We have common things such as digital input output. We can just drag and drop these blocks, okay, and create. You don't need to program. Just upload that program into MATLAB. For example, I have tried one scope test one. Okay, Blink MATLAB. So you can see. I went to the before that. Okay, I forgot to say that. Currently, you connect. Suppose you connected your device, whatever it is, whether it is Arduino Uno, Nano, etc. Anything is connected. Go to search device properties. Go for device properties, and you can see. Okay, I have disconnected this. You can't see it. Once you connect your Arduino to laptop, you can see ports. You have to check whether which COM port, communication port it is. Currently I'm connected to COM port 4. Keep that in mind. Go to MATLAB, go to modeling option. Okay, go to the model settings. I'm just waiting for output. Okay, model settings. There is something known as hardware implementation. Go to the hardware implementation, and you can drag. Initially it will be none. You have to change into desired external embedded system. So I am using Arduino Uno now, so let it be Arduino Uno, and go to the target devices. Check the host port connection, and just give it automatically, or if it is not working, just give manual. Okay, just give manual, and the port is 4. I have to change it to 4. Yes, 4. Give apply and OK. So now the system knows that this set of instructions, MATLAB knows that set of instructions has to be transported or communicated back to Arduino, which is at port number 4. This is also same with using Arduino IDMLs as well. And you can go to the library. this is, we need output, right? We are going to give output. So digital output, drag this, we are going to blink. We are making, I don't have any sensors, so we are going to blink the LED within the Arduino Uno, which is pin number 13. The pin number 13 is the default number of inbuilt LED. Just give 13, so it is going to the output is going to pin number 13, and we need a PWM generator to blink it. What we used to do is that we have a PWM generator within both inside the system as well as in MATLAB library. Just type PWM means pulse width modulation. You can either give this both are almost same, and give a constant because we need a DC old voltage, a specific voltage, right? So that should be constant. We are giving a constant voltage and we are changing its width, width of the pulse. That is what PWM does. If you connect it and if you go to the hardware part, you can run that. You can first of all run that. If so whatever the changes are there, the system itself suggests that these should be the changes. You can just give okay, so that most of the times you want okay block output pin number 4. So currently ignore this thing since I have used 2 pins. That was the problem. Since I have used here 13 pins and there are 2 outputs for a specific pins, that is causing this error. And once we upload it, once we are formatted it, there is go to the hardware part, and there is something known as build, deploy, and start. And if we click that, it will take some time, not less than 5 minutes. What it does is that the MATLAB is changing this into C code and it is getting transmitted to the respective Arduino.
Excuse me, Cheta.
Yes.
There's a question over there in the chat box.
Okay. I'll okay. I have to read it. Okay, I'll do that. ESP8266 node MCUs are also, you can use that. You can check that. If you don't see this, you can also, there is a package. Just go to the library which I show you. Okay. First of all, you have to have an account. You have to create an account. You can search for hardware support. You guys, when you download this, you won't get this pre-release version. It will be an original version, which is most probably R2021A. It is a newer version. It is not yet released. So if you in that you won't find any problem. Just it's getting loaded. It will take time. Let me check if other Simulink is possible. Okay. There is just go to the home page. There is if while clicking this add-on button, you are redirected to another page where you can find all sort of libraries. You can connect ESP, Raspberry Pi, Pico, STM32. So many things are available. You have to try. I have not tried ESP8266. I have tried ESP32. It worked pretty much okay. But the more complicated your program becomes, it's better to code. It won't come because it is a pre-release version. So I believe I have answered your question. It is possible. Hope. Okay, generation is completed. So once you upload it, it will blink. Similarly, I'll also show which I have taken video of that. That is for the first time which we did. We did implement this in a hardware during a real-time project. I'll try. I will try making that, and I will explain you that. We'll have a new page, new sibling page. We are not going to run it because we are using servo motors. So if you run this, there will be an error that the servo motor or the specific data point has not been connected. Go to the library, continuous servo write. This is servo. Uh, we need an analog output, analog input, and we can specify the pin number and give it. So specific input is there. We need an analog output. Continuous servo write. Continuous servo write. So what it is that in servo motor, it is going to run the servo motor using this block. So we need just like instead of analog, let us give a PWM thing. Because servo works on servo is a motor which changes from 0 to 180 degree, depends upon the steps. It's a discrete mode of motor compared to a DC motor. Right now I'm just giving this is not how you just connect these kind of block diagrams. You have to give a PWM function. It should be a constant. Should not be. Give a value, specify the duty cycle, number of period of duty cycle, which 2 seconds. This 50, I believe it is 50-second duty cycle, and click deploy. So once you do that, this is what we got. Once we deploy it, we were able to control the servo motor. That is, it is going from 0 to the duty cycle is 50. So 50, half the cycle it will be in 0, half the cycle it is 180. Okay, that's how we were able to implement this kind of small projects are supported here. You can do big projects, but I prefer not to do that because the more you do, it's better. If the project is big, it is better to code. You can try doing that still. That's it. You have the time period, 2 sample time, say everything's fancy. So that's how we did that project using 1 or 2 blocks. Yeah, less than 3. These blocks only sustain to do that. That's all. Now I'll show you something which can be used in mobile. Let me connect Google Meet through mobile. Just give me a moment. So I'm using my mobile here. So if you download this MATLAB in your mobile, you go to the sensor option, and these are all the sensors which are available in your mobile system. So you can take the acceleration, magnetic field, orientation, angular velocity, and position. And while giving whatever you need, just accept it and just start. So it is recording your position, magnetic field, etc. And once you stop it, these values are getting saved in the MATLAB cloud, where you can access it in the MATLAB cloud. You can also do small functions like small. You can try doing programs like equal to 6. So that's how you can do small program within the mobile itself. You don't need a computer or MATLAB. But as problem is gets bigger and bigger, you have to use MATLAB too. So that's all. So that's, and once you come back, okay, I have not shared my screen, right? I'm just logging into MATLAB. If you have any doubts, we can. The session is almost over. We are going to just. I am going to show you how you can further develop on MATLAB and how you can access that data which I stored in MATLAB. This is a sensor which I recorded just now. The sensor data. The position here. Position will not change as I am sitting. My system mobile is not changing. So you'll get the magnetic field orientation axis details with timestamp. There were 73 values. So that's, and you can directly take that. and here you are going to get the figure. So this is what I just did now. I switched on my sensor and sensor was tracking the x-axis orientation. I just moved my mobile. I think yes, I did. So that was it was tracking the mobile, and I was able to get real-time data. And like that, you can get you can find the distance traveled, etc. using formulas. You will get that latitude, longitude, etc. And that's how you can use MATLAB and MATLAB mobile and the sensors in your mobile. That's all. For the past 2 days, if you have any doubt, please let me know. So before I conclude, as a summary, what we did today is that we checked on mass damper system, and we did it using Simscape as a physical system. We did RC circuit. We studied on PID controllers and what is planned and about PID controllers. We started doing. We just worked on a simple half-wave rectifier, and finally we I give you basics on how you can download Arduino files, Arduino supported libraries, and how you can synthesize that, or how you can add that block, corresponding block, and how you can work on that. So if you have any more doubts, furthermore, I should have. There is something. If you have an account, even though you don't have any account, these are free for everyone. Okay, MATLAB on ramp, MATLAB on ramp, Simulink on ramp, Simscape on ramp, which I have shared those links in WhatsApp. And if you have a license, you can get certified in this. These are all certified courses: MATLAB fundamentals, MATLAB for data processing and visualization. Go through MATLAB on ramp, then MATLAB fundamentals. These are very helpful. Simulink is also available. Simulink on ramp, which I have completed once. I am going through it again. Simscape, Sage Flow, control design on ramp. So if you want to be thorough in MATLAB, I prefer to start. I prefer you can go through MATLAB on ramp, Simulink on ramp, Simscape on ramp, and Sage Flow on ramp. Rest is okay. And if you want to be proficient in something, specialize something, we can go through this as well. And I believe for trial purposes, it is accessible at least for 30 days. Thank you. That's all.
If there anyone have any more queries, you can share it over there in the chat box, or else you can unmute and ask.
So any doubts for the past 2 days? And if you are from CUSAT, what you can
Excuse me, Cheta, you got muted.
Oh, okay, I'm sorry. I'm sorry. Was my screen visible?
No.
Okay, I'll say. Is my screen visible now?
Yes, Cheta.
Yeah. Okay. This is CUSAT website. This is for CUSATians. Just go to CUSAT website, cusat.ac.in. Scroll down. You can see it's stuck. You can see there's something known as matlab.online. Once you click it, it redirects you to CUSAT's MATLAB site. Just sign in. Just get it started and give your CUSAT mail ID. Once you give your CUSAT mail ID, you will get the license. And you can also access all these courses, which these self-paced courses and certification courses. and you can prove your proficiency. So, any doubt? If we don't have anything, then organizers, shall we wind up?
I think no more queries. So the feedback form is attached with the chat box, and I welcome Aparna to for the vote of thanks.
Hello, am I audible?
Yes, Aparna.
Okay, thank you, Shweta. Hi, good evening, everyone. I am Aparna and I'm here to propose a vote of thanks. First and foremost, I would like to thank Harigovind M for taking this session, introducing us to MATLAB and Simulink, and giving us an idea about how to use them for various small projects and all. Thank you, Harigovind Etta. It was really an informative and a wonderful session. Thank you so much. Last but not the least, I would like to thank all of you for attending this 2 days workshop on Introduction to MATLAB and Simulink. Hope you guys found this session beneficial and useful and you got an idea about how to use them for your future projects and other things and all. So thank you everyone for attending this session. Thank you so much.
Shall we wind up then?
Yes, Cheta.
Okay, thank you. Have a great weekend. Bye.
Thank you, Cheta.